Okay guys, let's take a look at our lesson today. We are actually going to spend 2 days on L'Hopital. The first day, today is our first day, we are only going to look at two types of indeterminate forms, which is 0 over 0 or infinity over infinity. This one, certainly we're familiar with, the 0 over 0. We encountered that in Unit 1 with limits. We looked at that. And when we were working with a limit and we got to the form 0 over 0, remember we were like, don't stop. We can do something to fix this. It doesn't mean it's 0. It means there's an answer. We just need to keep working for it. Well, we're going to learn today how to do that an alternate way. Instead of working through it, well, for the most part, instead of working through it algebraically, we're going to be able to use L'Hopital's rule. It only works on 0 over 0 or infinity over infinity, period. So it is a powerful rule. I think it's pretty cool. I mean, imagine how many limits that he would have had to do to recognize that pattern. I mean, that is pretty cool. But at any rate, he recognized the pattern, and if you so here's the way it works. If you substitute the number in, whatever number you happen to be for your limit, and you get 0 over 0 or infinity over infinity, you are eligible to use L'Hopital. You can use it. Okay, so that's the criteria. You have to, when you sub in the constant, you have to get 0 over 0 or infinity over infinity, or you cannot use it. So let's talk about that. Infinity over infinity and 0 over 0 used to mean do algebra. Okay. Now, since you're going to learn L'Hopital's rule, whenever you encounter that, you are allowed to use L'Hopital's rule. You don't have to revert back to the way that we used to do it in Unit 1, where you had to use algebra. Now, I will tell you, it is possible for L'Hopital's rule to fail. And what I mean by failing is be in an ever-ending loop that you can never get out of. Okay? So, we may have to supplement L'Hopital with algebraic techniques, or we're going to have to, in some cases, we're going to have to supplement it with algebraic techniques. Okay, so that's just to let you know. Now, the way the rule works, so we've found out when we can use it. Now, how do we use it? We actually are going to do something that some of us have been wanting to do since we started quotient rule, which we're not allowed to do. This is not really like doing a quotient rule. This is really, I mean, absolutely just taking the derivative of the numerator, period. Taking the derivative of the denominator, period. Okay, that's the way it works. It's a rule. It's not, I'm not taking the derivative of the quotient. So don't do quotient rule. That's not what this is. This is a rule that he came up with that actually is very cool and works many times after 1 or 2 applications. Let's talk about what does that mean, 1 or 2 applications. What that means is I sub my constant in, I get 0 over 0 or infinity over infinity. I use L'Hopital. Then I sub the constant back in, and I get, again, 0 over 0 or infinity over infinity. So that means I can do it again. Okay, like the second, we keep going, taking the derivative of the numerator, derivative of the denominator. Just keep going. I mean, we could continue to use the rule until we get an answer, like maybe at some point it'll turn into 2. Or maybe at some point it'll turn into 2 over 0. That does not mean L'Hopital, does it? We know that does not mean L'Hopital. That is not an indeterminate form. That is undefined. That's where we stop and figure out whether it's positive or negative infinity. Okay, so those are kind of the ways that this works. Okay? Questions about the technique? We're going to practice it several times. All right. Day 2 of L'Hopital's, which we'll do next week, is going to involve other indeterminate forms. So right now we have only talked about the indeterminate form of 0 over 0 or infinity over infinity. Well, there are a lot more. Not a lot more. There are several more, and we're going to deal with those in day 2. Okay, so day 1, we're just going to handle these 2. All right, so let's take a look at our first example. We have the limit as x approaches 0 of e to the x minus 1 over x cubed. Okay, my first tactic, as always, is to sub in the constant and see what I get. So I put 0 in, e to the 0 is 1, so I get 0 over 0. Okay, that means that this means I can use L'Hopital. So let's use L'Hopital. What I would like for you to do is just indicate that you're using it with just writing LH for me. That's just telling me that you're using L'Hopital. You don't have to show me how you found the derivatives or anything like that. Just write LH to show me that you are using L'Hopital, and then use L'Hopital. So the derivative of the numerator, derivative of e to the x is e to the x. The derivative of negative 1 would be 0. Okay, over. So the denominator, the derivative of x cubed would be 3x squared. So once we do L'Hopital, we stop and we sub in again and see if we are good to go. So I sub in again, and I get e to the 0 is 1. And I put a 0 in here, and that gives me 0. Okay, and actually we just talked about that, didn't we? That doesn't mean use L'Hopitals again, right? That's not an indeterminate form. That is undefined. 1 over 0 is undefined. So we have to decide whether this is going to positive or negative infinity. Now, I mean, you could try to graph it. It wouldn't be that easy to graph. So let's think about numbers actually really coming from either side of 0, whether I put in a 0.1, a positive number, or like a negative number, what is that going to do to this value? It's going to be positive regardless, right? There's nothing I can do to e to the x to make it negative, and there's nothing that I can do to x squared to make it negative, right? So this is going to tend to infinity. Okay? How are we? That's our first one. All right, let's look at the second one. We're going to look at the limit as x goes to 0 of 1 minus cosine x over x squared. All right, so let's sub in the 0. So cosine of 0 is 1, and so that's 0 over 0. So that means we can use L'Hopital. All right, so let's do that. So L'Hopital, so limit x goes to 0. All right, so let's use the rule, and that is take the derivative of the numerator. So the derivative of 1 is 0. The derivative of negative cosine is sine. And the derivative of x squared is 2x. So we stop and we sub the 0 in. So I get sine of 0 is 0. And 0, that's 0 again. Okay. So I am eligible to use L'Hopital again. Now I will say we have another technique that we could use to solve that. You can probably see what that is, right? So remember, we have a limit as x goes to 0 of sine x over x. That's a special limit. Now I know we can do that, but I want to demonstrate L'Hopital one more time because I am eligible to do that. Okay, so yes, you don't have to keep doing L'Hopital. Really, you can solve the limit how you like, but I'm just showing you how to use it. So let's just apply it one more time. So L'Hopital. So the derivative of sine is cosine. The derivative of 2x is 2. So cosine of 0 is 1 over 2, and that is my limit, which is the exact same thing you would have gotten had you applied that special limit of sine x over x, wouldn't you? You've gotten the exact same thing, you've gotten a half. Okay, so it does not matter which way you do it as long as you're using the proper technique. Okay, we okay? Mm-hmm. Oh yeah, you can do it algebraically. You do not have to do L'Hopital. I'm just showing you how to do L'Hopital. But yeah, there's lots of different ways to solve it. It's really what your preference is. Okay? All right, let's take a look at the last example. So this one is, we're going to 0 from the right, and this is natural log x over cosecant x. All right, so we're going to have to think about their graphs, or I will. Maybe you guys have these values memorized. I need to think about their graphs. So natural log x goes like that, right? So that's headed to negative infinity. Cosecant x, let's see, cosecant is the reciprocal of sine. So that means there's an asymptote here, and it looks like that, right? So it's going to infinity, which it's fine. It doesn't have, it can be negative infinity over negative. It's just to one of the infinities. So don't let that disturb you. It's okay. It's okay that there's a negative there. So that means I can do L'Hopital. Okay, so let's do L'Hopital. All right, so the derivative of natural log of x is 1 over x. The derivative of cosecant x is, do we remember? Negative cosecant cotangent. Good, so we stop. We try again. Well, hopefully you remember the graph of 1 over x looks like this. So what happens as I'm headed to 0 from the right? Going to infinity. And this cosecant guy multiplying undefined by something, and actually cotangent is also undefined at 0. So it's like double undefined. I don't think we're going to get anywhere there, right? Doesn't look like it. So there's an asymptote there. It's going to infinity. Alright, so I could apply. I am eligible to do L'Hopital's again, but let's think about this before we just blindly jump in and do L'Hopital. What's going to happen if I keep taking the derivative of this numerator? Yeah, so the derivative of 1 over x is negative 1 over x squared, right? Which is still a problem. Am I ever going to be able to get out of this problem? No, not with L'Hopital. So here, L'Hopital was beneficial to us because we were able to get rid of natural log x. I mean, working with natural log of x, that with techniques that we've learned so far, is just not going to be pretty, right? It's not going to be good. So we were able to use L'Hopital to get rid of natural log of x, but now we're going to have to rely on algebraic techniques. We're going to have to just pull out all of our algebraic tricks and work it. So I'll just show you what I did. As we know, with trig, there's all kinds of things you can do. I'll just show you the way that I approached it. I turned the cosecant and the cotangent into forms of sine and cosine. So we are done with L'Hopital on this problem. So cosecant is 1 over sine, and cotangent is cosine over sine. So continuing to work our trig and algebra, I have 1 over x times, so that's going to be negative cosine over sine squared, right? And I flip it upside down to fix my complex fraction. So I'm going to be multiplying by sine squared x over cosine x, and I'm going to have a negative in there. I'm just going to put it there. It doesn't really matter. Okay, so let's think back. Let's use the limit rule. I used the limit rule. I split this apart. I put sine over x in one limit. So limit as x goes to 0 from the right. I took one of the sines and paired it with the x times limit x goes to 0 from the right. I took the other sine and paired it with the cosine, which is actually tangent, right? Negative sine over cosine is negative tangent. So let's do our rules. So this is a special limit, and that's 1. So we need to think about what happens to tangent. So I'm going to draw a negative tangent. I mean, if you know the values by unit circle, you can do it that way, but I just like to think about it graphically. So negative tangent looks like that, right, with asymptotes there. And so at 0, it is actually 0. So 1 times 0 is going to give us 0. And so that is our limit that we couldn't finish with L'Hopital. We were able to start with it, but we just couldn't finish with it. It was just going to put us in a loop. Okay? Does that make sense? Questions?